Here is the mystery solar system question dealing with seasons. There are two parts to this question. The first part asks you how long the seasons last. You also need to explain how you can tell. The second part asks how extreme these seasons are. Remember that the key idea with seasons is that the temperature changes from one part of the year to another. So when we say that the seasons are extreme, we mean that there is a big difference between summer and winter. It does not mean that it's always hot or always cold on the surface. It's the difference between the seasons that makes them extreme. So how do we find the length of the planet's seasons? This part is pretty straightforward. You can start by assuming that there are just 4 seasons. This works because the seasons are defined by the planet's tilt. So if there's any tilt at all, then there will always be a time of year when the North Pole is pointing most towards the central star. And half a year later, the South Pole will be pointing most towards that star. These are the solstices. Halfway between those times will be the equinoxes when the equator points at the central star. We're going to assume those seasons are all the same length. That's generally true so long as the planet's orbit is close to a circle, like the Earth's orbit is. Since your mystery solar system doesn't tell you whether the orbit is circular or not, we'll go with this simple assumption. Later on in the semester, we'll see how seasons can get more complicated when the orbit isn't a nice circle. So if there are 4 equal seasons, we can simply divide the planet's orbit into 4 equal parts, and that tells us the length of the seasons. Note that you have probably already done something like this in one of the Your Turn questions from the online lecture on the sky, where you estimated the length of the seasons on Saturn. This question is asking the same thing. To find out how extreme the seasons are, we need to go back to the cause of the seasons. Remember that seasons are caused by the planet's tilt. So the more tilted the planet, the bigger the seasonal effect will be. A tilt of 0 degrees means that the planet's poles are perpendicular to the orbit, and hence there are no seasons. When you are on that planet, you'll get the same amount of sunlight at the same angle all year long. The Earth has a tilt of 23.5 degrees, so that determines how extreme our seasons are. A planet with a much larger tilt will experience a larger difference between summer and winter, meaning more extreme seasons. The maximum possible tilt is 90 degrees, so the closer that tilt is to 90 degrees, the more extreme the seasons will be. However, when you look at your mystery solar system table, you may see some planets that have tilts larger than 90 degrees. What does that mean? In fact, tilts larger than 90 degrees imply that the planet is spinning backwards compared to its orbit. We call this a retrograde spin. In our solar system, Venus does this. So to compare your planet's seasons to the Earth when the tilt is larger than 90 degrees, all you need to do is subtract that tilt from 180 degrees. Then you can compare it to the Earth's 23.5 degree tilt. Let's look at a couple of examples. The first one has a year that is only 0.6 Earth years long and a tilt of 45 degrees. For part A, the length of each season is 0.6 divided by 4, which equals 0.15 Earth years. That's less than 2 months. In part B, the tilt is almost twice as large as the Earth's, so this planet will have very extreme seasons. Even in a mid-northern latitude, the sun will be high overhead in the summer, and in winter it will barely get over the horizon. In the next example, the year is 1.2 Earth years, and the tilt is 160 degrees. Once again for part A, the length of the seasons will be 1.2 divided by 4, which equals 0.3 Earth years, or just under 4 months. For part B, the tilt is larger than 90 degrees, so this planet is spinning backwards. This means we need to subtract the tilt from 180 degrees. 180 minus 160 gives 20 degrees of tilt, just slightly less than the Earth's tilt, so the seasons are probably about as extreme as on the Earth. If you want to take your analysis to the next level, Think about how the length of the seasons affects how extreme they are. This is a secondary effect. The tilt is still the most important thing, but it can push your answer a little one way or another. See if you can figure out which way the length of the seasons impacts how extreme they are.